the course outline, right? I believe that everyone must have got a copy of this course outline, that which all topics you will be covering during the LTM training. So that it starts with the installation, that how we can install the big IP. Then second is it goes through the load balancing methods and how we can utilize them. Third is health monitor. Fourth is profile. Fifth is persist. I mean, under profiles, then it is something that we are going to cover, like persistence profile, the SSL profile. Will do some sort of labs that will also cover the NATs, SNATs, the high rules, the high availability. And then we have got the command line also, right? And then under profiles also, like not only we are going to cover the SSL persistence, but also we have got some other profiles which also we will cover during this as part of this training. The IAPs to deploy your applications, right? And the virtual servers and different types of virtual servers and their use cases and how we can create them. And of course, we have got the monitors. Now, I'm not going to cover all these topics in two different parts. Basically, if you look at here, and under the, if you look at the course outline, then profiles are divided into two parts, like profiles and then profiles part 2. So I'm not going to cover them into two separate parts. Once I start with profiles, then I will get it finished. Once I start with the virtual server, I'm going to get that finished. Or maybe if I'm starting with the high availability, I will get that finished. But these all are the topics that you are going to cover, including the command line. So you would learn that how to work through the command line on big IPs. So these all are the topics that you are going to cover during the LTM training. Now, because LTM has a heavy dependency upon the basics of the networking, right? It's not like I go and directly start working on the big IP. I can do that, but it will be, I feel that it is a little injustice for everyone if I just go and start working on the big IP, or just start the big IP LTM training. Before understanding LTM, the local traffic manager, because these topics belongs to LTM only, and you have enrolled yourself for the LTM training. So I should cover the LTM module only, right? As we cover the DNS. But I feel it a little, injustice if we directly go and start working on the LTM, because see, without understanding the big IP, like if we don't understand the behavior of the big IP, because LTM is a module of the big IP, right? So if we do not understand big IP well, then it will be difficult for us to work on LTM or maybe GTM, whatsoever module you are working upon, right? So the first step should be to understand the big IP. On big IP, like you must learn that, okay, how to perform the installation of the big IP, then if needed, then how to upgrade the big IP, how to create VLANs, how to allocate IP addresses, how to create, like we have got a concept here called, kind of VRF, right? That we have got here on the big IP. So we should be knowing that how to leverage all those options. And then also we have got the partitions. Then we should think about, or we should talk about the partitions. Now, all those topics are not available in this list, but we should cover them. Although I know that if you take the training from F5, they have divided this training into multiple modules. So if you take the training for big IP, then only they are going to cover all those topics. And if you are taking the training for LTM, then they will not talk about the big IP. I know that, that training has been divided into two separate modules. But, as I mentioned before, it is very difficult to understand the LTM directly if we do not understand the functionality of the big IP, right? So big IP is kind of like, it's a device, right? Big IP is a device that come from F5, right? So we need to understand the functionality and features of that device. So once we are good with that device, although some of you are repeating this, not repeating, I would say that some of you were already there with me during our GTM training, Global Traffic Manager training. And at that time, I never talked about the big IP. And there was a reason behind that. Why? Because the training, I don't directly start with the GTM. I always start with LTM. And whenever I get started with LTM, I first cover the big IP, and then I start with the LTM, and then I go for GTM. So this is how it works. But some of you already, like maybe you were in hurry or you had some project requirements, and that's the reason that you joined directly GTM and you did not join from the LTM. But ideally, we recommend people to join the LTM training first, like go through the big IP and then LTM, and then start working on the GTM. Because when you start working on GTM, then you are already familiar with the functionality of the big IP and then LTM, because all those things are in used when you are working on the GTM. So if you do not have understanding of the LTM and the big IP, trust me, it is very difficult for anyone to work on the GTM. Now, if you do not have the understanding of the LTM and big IP, and let's say I taught you the GTM, and also you learned, okay, this is how things are working in GTM, and this is how you should create those objects and leverage them, right? But point is that you would not have the background knowledge. You can go ahead and you can create those objects, you can start using GTM, but you would not have the overall background knowledge that how things are happening actually. So if you want to take the background knowledge, then it is important for anyone to go through the LTM training first and then start with the GTM. In fact, before taking LTM training, you should go through the big IP training. So you should learn big IP as a device. So as a device, learn it first and then start with LTM and then start with GTM. This it is our sequence, right? But if in case someone saying that, okay, no, I'm already comfortable with the LTM and there is no need to wait until the next batch gets started with the LTM or maybe big IP, so I don't want to wait for that much longer period of time, then we say, okay, if you are already familiar with the LTM technology, go and join the GTM sessions, right? So I mean that's our way. So since now we are again back to the LTM, and as I mentioned, I'm not going to start LTM directly. Before that, I would get started with the big IP. And now why it is important for us to cover the big IP prior to we start with the LTM. Let me show you something here. Okay. So I'll take you through a F5 website quickly. So let me open up the f5.com. So f5.com.
Is there any other websites also? myf5.com
Yeah, there
related with
are.
F5?
There are
Okay.
many other websites, but we are not talking about them yet. That is
Okay.
part of the resources, right? So once we start talking about the resources, then we can have a discussion around those different types of websites which are available, and then how to utilize them, or what is the purpose of those different URLs or domains. Okay. So for now, let's get started with the resources, and under resources tab, I'm at their primary website. It's a primary website. It's a front face of the F5. Since it is a front face of the F5, right? This is f5.com, and whenever you try to learn about the F5 very first time, then you always go and start accessing this F5. So now, once you are at f5.com, there are multiple tabs. Like you can talk about the solutions, you can talk about the products, right? That F5 is offering as of today, right? And we will talk about that, especially this product line. That how many different products are being offered by the F5 and what are their use cases. So I will have a discussion around that also, because it is not only important for us to understand the big IP, but also we should have an idea that which all products are being offered by the F5 as of today. Like obviously, if we go for the Cisco training, let's say routing and switching, and if we don't know that which all um, platforms are being offered by F5 when it comes to the Ethernet switching. So I mean, we know everybody knows that, okay, there is a Catalyst series, right? And then obviously we have got the routers. So for routers, we have got like different series of routers, like industrial router series, and then we have got ISR series, then we have got ASR series, then we have got some other series of routers as well. Point is that as we know about the Cisco devices in similar way, in similar fashion, we should know about the F5 offerings or F5, offered devices or platforms. So we will talk about that as well. But for now, let's talk about the training and certification of the F5 technology. So if you go to resources here, and then if you go to documentation, education, right? So let's go to the education first, right? And under education, if you go to the professional certification, that which all certifications are being offered by the F5. Because I just wanted to make you understand that why it is important for us to understand the big IP first, not directly LTM or maybe GTM. So if you look at the certifications and their requirements, so this is how the F5 has designed their overall certification tracks. It's like quite similar to Cisco. I'm referencing Cisco again and again, and there is a reason behind that, because most of us come from Cisco's background, right? Most of us, I will not say all of us, but most of us comes from Cisco background, and we are quite familiar with the Cisco certifications and the technology. So that's the reason that I am taking the reference from Cisco. So now, if you look at this certification track, so you would find that they are starting with the 101 exam. So if you talk about the 101 exam here, this is the very first exam, and it is an essential exam before you take on 201 or maybe 202, no matter that whatever you are trying to, whatever you are planning to take on. But if you are trying to take on the 201 or maybe whatever 202, the minimum requirement or the dependencies over the 101 exam. So you must obtain this 101, that's mandatory, and there is no bypassing. Okay, in F5 there is no bypassing. Like in Cisco, people does sometimes that bypassing, which is technically available on Cisco, right? So people sometimes do bypassing, but in F5 there is no way to bypassing anything, any certification over here, right? So first you have to take 101. Now what is 101? So if you look at this 101 examination here, it's all about the basics of the F5 technology, right? It is all about the application delivery fundamentals, this 101, where we learn about the functions of ADC. Remember that when I say ADC, application delivery controllers, which means I'm also talking about the load balancers like LTM. LTM is also known as ADC, application delivery controller. So basically here, under application delivery fundamentals, we talk about the ADCs. And even before I get started with ADC, let me show you something here. So first you start with like, what is OSI model? Then what is TCP/IP model? What are the headers and their uses, right? Headers and their uses. The TCP three-way handshaking, right? The SSL workings, the SSL working, like how SSL connection comes up between the client and the server. Then you have got the HTTP function, that how does HTTP works, right? So when I say how does HTTP work, so you need to know that when you are browsing any website from your local laptop, then in background HTTP is always working. Like here you could look at, I accessed this f5.com, but what is working in background? It's HTTP, although it is a secure one, so I will call it HTTPS, but at the end of the day it is HTTP, right? It just got secured by the SSL. So you need to understand that how HTTP is working. You need to understand that how FTP is working. You need to understand how DNS is working. So these all are the applications that you need to focus on, and you should have kind of knowledge that how these applications are working. Because if you don't understand these basics like OSI model, the TCP/IP model, three-way handshaking, the SSL connectivity, by leveraging the digital certificates, and then even the processing of the digital certificates, because see, certificates are being used by all secure websites. So whenever we talk about the HTTPS, so HTTPS, which means that we are talking about the digital certificates. So you should be knowing that, okay, what is certificate authority, then what is the root CA, right? And then we need to know that, okay, what is the identity certificate, right? And all those kind of things, right? So we should have that kind of knowledge, and that's what you learn in 101. That's all about the 101. And not only that, but also we talk about the ADC's application delivery controller, which means the F5 big IPs, a little from big IPs, a little from the LTM. That is what this 101 has, but nothing into much details. Okay, like when I say nothing into much details, which means I'm referencing here the F5 technology. So they do not cover F5 technology in details here. They just expect you to have some basic knowledge around the F5 big IPs as well as F5 LTM during this 101 exam. So if you have that kind of knowledge, you can easily take on this exam 101.
One query is regarding the headers of packets here.
Mhm.
I'm requesting you to please guide when we touch the section of headers, from where we can get a detailed knowledge of the headers of
Mhm,
packets.
mhm, mhm.
At the time, you can suggest me,
Okay.
right?
All right, sure, we'll do that, right? And the next exam that you need to take on is the 201. Now, if you look at here, the 201 is all about this. once you crack this exam, right? Once you obtain this certification, you have cleared this exam 201, then only you become the F5 CA. So when I say F5 CA, which means now you are equals to CCNA in Cisco, right? So this is certified administrator. So now if you look at the big IP, this 201 is all about the big IP. Now they are not talking about the LTM. They're not talking about the GTM. Obviously, they have to talk about the LTM here a little. They have to talk about the load balancer as well. But mostly this exam is focusing on the big IP as a device. So big IP is a common device. Let me tell you one more thing. Like in Cisco, you might have heard that there is a router which does routing. Then there is a switch which does switching, and then there is a firewall. And these are different platforms actually. Like in Cisco, router is a different component. The switch is a different component. The firewall is a different component. So these all are the different components offered by Cisco. But in F5, when we talk about the big IP is a common device. Big IP is a common device, although it can be like virtual in cloud, or maybe it can be hardware, but at the end of the day, it is a device. The big IP is a platform. Now, on this platform, like over this big IP, you want to use it as a LTM, you can use it. You want to use it as a GTM, you can use it. You want to use it as a APM, you can use it. You want to use it as ASM, which is now it has been renamed as WAF. So you want to use it as AFM, fine, you can use it, right? So point is that you have got a common device, and then that common device can be leveraged or can be utilized as a different component, like LTM, GTM, right? APM, ASM, a same device, right? I mean, you have got, let's say you want to provision, you want to have a WAF deployed, which means you have to purchase a big IP. You want to have a APM deployed, which means that you have to deploy the big IP. You want to deploy GTM, which means big IP, LTM, big IP. Now, if you don't understand the functionality of the big IP, how come you can deploy the LTM? How can you can deploy GTM, which is now renamed as DNS? Or maybe how you can deploy the APM, or maybe ASM, which is WAF, right? Or maybe AFM. AFM is firewall module. So how you can deploy them if you don't understand the big IP? So understanding big IP is so important. And you see that you have not covered the LTM yet, but now you are CA, certified administrator. Yes, Gurpreet, say it.
So what is NGINX F5? Because it is not covering in this section. The screen in which it is reflecting right currently, it is not covering NGINX F5.
Even
Is
in
it
this
different?
training, even in
Yeah,
this
no,
training,
no,
we
no,
are
no,
not
no,
going to touch
not
this.
not this training. I'm asking a part of this training. Is it different from the thing which we are going to do, or which are
Yes,
we
it
going to
is. It
study?
is
Yes, right.
different. Yes, it is different. I mean,
Okay.
it is a load balancer at the end of the day, but
Okay.
it is an application-based load balancer, which is which is deployed virtually actually. There is no
Okay.
physical
Thank
device
you.
for NGINX and all that, right? It is a virtual load balancer all the time. So ideally, that was meant for the cloud, the public clouds like AWS or maybe Microsoft Azure. So that's where you could utilize the NGINX.
Okay. So where we are using NGINX, is it not possible to use this virtual edition of Big IP over there?
It is possible,
Okay.
but then
Then
it's a little expensive at expensive side as compared to NGINX.
okay.
And also
Expensive
the
kind of some
features are,
feasible thing, right?
so depends like what you actually wants to perform, the throughput and everything. It will be depending upon that. Well, now we have got this big IP, right? So 101, 201, these are the two exams. Once you are done with that, then only you become the CA certified administrator. So again, like everything is depending upon the big IP. And thereafter you start, working on the individual modules like LTM, the DNS, the ASM. Now it's been renamed as WAF, right? And then APM, which is Access Policy Manager, right? So that's what you have got there. And then under Security 401 exam, you would even have the AFM, right? The firewall module. So point is that everything is depending upon the big IP and the basics. So if your basics are not that strong, let's say you don't know that how three-way handshake works, or what are the properties of TCP, how does it work, what is reset, the different flags used by the TCP, and then how SSL is working, right? Especially because in most cases you work with web applications, right? In most cases you work or you deploy the web applications on your F5 load balancer. I'm not saying that that is the only type of application that you deploy on the load balancers. But in most cases, like I would say that 80 to 90%, or maybe more than that, right? I mean, as per my experience, other than the web application, we deployed only SFTP based applications onto load balancers, nothing more, right? So in most cases, like I would say 99%, in 99% cases, we used, or I deployed the web based applications on F5. So if you do not understand the HTTP a little here, not a little, I would say a little more, right, as compared to like what you understand in regards with the routing and switching, you need to understand this HTTP in little more detail, like how HTTP is working, different messages or different request methods used by HTTP, like what is the purpose of that? Like, I don't know how many of you have heard about the HTTP different request messages or request methods. Like it could use get method, it could use the put method, then it could also use the delete method. It could also use the there are many methods, right? So mainly you use the get method if you are trying to get some information. So I mean, there are so many different methods can be used by the HTTP, and then you have got pipelining, you have got HTTP keep alive, so different features of the HTTP are there. So we need to understand that how HTTP is working, and to understand that what I will be doing here, that I will try to access one insecure or I would say non-secure website, and then I will take the capture of that, and then we'll display you that, look, this is how the HTTP is working. Because if you are trying to understand HTTP while it is secured by SSL, and even if you are doing the packet capture using Wireshark, still you would not be able to see any payload inside, those packets. So better that we try to access, or we try to learn about the HTTP with a unsecure website, right? So we just have to make sure that we are using only HTTP, and then do the packet capture, and then analyze them. That okay, first TCP connection came up. Once TCP connection came up, then HTTP is sending its requests, and then also it is waiting for the response messages. Once response came back, then again it sent the another request, right? So that way you will have to understand the HTTP completely. So that's what I have a plan for you, that to make you understand HTTP in a better way. I would go ahead, and then I would I would access a website which is not secure by the SSL, and then we can capture the packet using Wireshark, and then we can analyze them. So I mean, that's my recommendations for all of you to understand to understand the HTTP. But again, it's all your decision, like how you want to take it further.
Correct.
But
Can we do these things same with TCP on real scenario? Like how can we make a three-way handshaking with Google server? Can we trace that packet in Wireshark and see?
TCP can be seen. TCP connection, right? Like how TCP
Yes.
connection is coming up, that
Right,
can be
right.
seen. But on top of that, nothing will be, like, you will not be able to see anything on top of that, because then thereafter the SSL will take place, right? And your payload will get encrypted by the SSL.
So
So
what is
TCP,
payload? What is payload?
very nice, Gurupreet ji. It's your data.
Sorry, sorry for asking for this question because I have experience in corporate, no issue. But
Ah,
sometimes what I'm thinking, I want to compare with trainer. What trainer thinking about that thing? That's why I'm asking.
no, what I'm saying is that HTTP payload, right? So HTTP data, whatever
Okay,
data is inside that, right? Because that data
fine,
is
fine.
encapsulated by the HTTP header, and then it is given to the SSL. Then SSL will, encrypt that data. So
It is
I
a
was
kind
talking
of
about
data.
that
It
payload.
is exactly equivalent to data payload.
I'm say, I'm sorry, say it again.
I said, is it exactly a HTTP data or it is equivalent to data?
You can call it normal data. You can call it payload, right? You can call it
Fine,
HTTP data.
fine.
It's the
Thank
same
you.
thing. Because at the end of the day, at application layer, you are using HTTP. That's the reason that you will call it HTTP data, because it is, in reality, it is HTTP data, right? And then payload, you are calling it payload because that's the actual user data, right? That's actual user payload that you are taking through. And then third, what I said, the payload, then HTTP data, and then
Yes, sir.
just data, just data, just data, right? So yeah, you can call it just data. Fine.
Right.
But we
Thank you.
should be more specific. you know. More
Yeah, yeah.
specific language is is a little more important, especially while taking the interviews or maybe communicating with the customer and all that. So more specific terms are more important. Actually, we should be more specific while explaining anything, correct?
Yes, yes,
Especially
yes.
from a trainer point of view, like if any one of you is looking for the training kind of profile, in future, then you have to be more specific while explaining anything, right? Okay. So that's about the 201, right? And in fact, we can go through that content as well. And then finally, we will get started with this big IP LTM, right? The LTM, local traffic manager. Now, thing is that if you are considering or if you are thinking that we're gonna cover 101 separately, 201 separately, and then we will continue with the 301 LTM, right? Because within 301 also you have got like A and B, but it's all about the LTM, right? So that is not technically it is not possible for us to cover all these modules separately. It is possible, like for me, it is possible, but point is that then none of you would have enrolled yourself with I-MEDITA because the fees and the charges would go higher. Why? Because it is going to take long time to cover all those separately, right? So what I have suggested our team, the I-MEDITA's administration, then let's get everyone enrolled for the LTM training, but then in beginning, like at least for 2 weekends, like at least 4 sessions, I can cover on this one, the basics, like how TCP is working, how HTTP is working, what is IP address, what is MAC address. So if someone is not aware with that, like I'm not sure that if Mandar you have that kind of knowledge that what is IP address, how does it work, what is subnetting, and then similarly it goes with the MAC address, like how does it look like? So what is VLAN, right? So I mean that is very important for us to understand as a load balancer engineer, because it's not like if we are not working in a network, then we don't need to know about those networking components. No, we still need to know about those networking component, even though we are working on a load balancer. But as let me tell you, even on load balancers, you need to create the VLANs. Like VLANs, obviously it's a one-time job, but still you have to create that. The VLANs has to be created on big IP. The IP addresses needs to be allocated. The static routing, because we do not really follow the dynamic routing concept on the F5 big IPs. We do not enable dynamic routing. In most cases, we rely on the static routing. So then how to add those static routes? So if you are adding a static route, then you should know about the subnets, right? Because if you don't understand the subnets and then you are trying to add the static routing, I mean, you might make the mistakes as well. So point is that all those networking components, right? Being a load balancer engineer, it is essential for us to have the network knowledge as well. Because everything is there, the VLAN is there, the Ether channel is there, the MAC address is there, the ARP resolution is there, then you have got the IP addresses, you have got a static routing, right? Even though you would be adding a default route, right? So you have got everything, whatever you had as being a network engineer. So all those things are still out there. On top of that, now since your big IP, your F5 load balancer is a layer 7 device, so it can also work at the application layer of the OSI model. So not only you are going to work at network layer, but you will take it until application layer of the OSI model. Why? Because it is a layer 7 device, right? You can also call it proxy, but we call it actually reverse proxy. And why do we call it reverse proxy? That is also something that I will explain you, because there are a couple of terminologies that we use around the proxies, like, okay, whether it is a forward proxy or reverse proxy, whether it is a half proxy or it is a full proxy. So let me tell you, big IP is your reverse full proxy. It can work as a reverse full proxy. Obviously, it is a reverse proxy, no doubt about that. But then whether it is working as a half proxy or full proxy, it will be depending upon that how you have deployed it, right? Because sometimes you'll be deploying it in a DSR kind of in a DSR mode. When I say DSR, which means it's called direct server return. So your request will go through the load balancer, but then it will return back directly from a server. That's called DSR deployment method, right? Direct server return. So I mean, it will be depending upon that how you are deploying it. But yes, we should be knowing about all these concepts. So I hope that now you got to know that why it is important for us to understand the big IP and of course the basics, because even if you are looking to take on the 301 A examination, prior to take your LTM exam, it is mandatory for you to clear 101 and 201, right? And in fact, if you are doing the troubleshooting and if you don't understand the basics of networking, then it will be hard for you to perform the troubleshooting in the production environment. And also, if you don't understand the functionality of the big IP, that how it is processing the packets and everything, then again it will be difficult for you to perform the troubleshooting. So not only we need to know about the packet level information like headers and everything and TCP functionality, HTTP functionality, but also equally we have to understand the big IP, that as a box, as a device, how does it perform, right? What all sort of capabilities it has got, so that we need to understand. And that's the reason that I always push everyone to take or to go through these concepts like 101 and 201 before going for the LTM directly. Because see, if you are going for the LTM training, then we have to add that prerequisite that okay, you must have the 101 and 201 sort of knowledge. And we get very few people who are already working on the big IPs and they have some prior knowledge about the big IP and the basics of like HTTP and all that. And that's the reason that what I have suggested everyone, that okay, first 2 weeks I will cover the basics like headers, TCP connection and all that, and then thereafter I will continue with the big IP then.
So we are going to cover A and B separately, or like we'll combine it together.
No,
Because
there is
for me, I'm comfortable with one. I'm comfortable with one on one or two on one. Because currently I'm
no,
working on
I'm
the
not.
production environment.
I am not going to cover any one of them as a separate module. Okay, I'm not going to cover 101 separately, 201 separately, 301 A
No, no, no.
separately,
I'm asking
301
about
B
301
separately.
A and B.
No, I'm not going to cover them separately. Why? There is a specific reason. Again, it will make your double time, right? And also in terms of finances, it will make um, you know the double fees as well. So we combined it that. So it's LTM. We are not covering about or we are not going to cover 301A separately, 301B. No, there is a training called
Okay.
LTM training, and there will be a combined training for A and B both.
Okay. But we are going to cover a syllabus completely for A and B.
Yeah, absolutely.
Okay.
And the topics were already shared with.
Yeah, I went through the topic list. But
Yes.
I mean, actually, the reason. So most of us are kind of experienced candidates. So would request to focus more on the LTM in detail. Yeah, definitely there is an outline that we definitely
Yes,
need to prefer.
that's what I'm saying. That see, outline was already shared with all of you. We're gonna focus on that outline. Yeah, if we get the time, then obviously we can also go little beyond that, but not completely.
Yeah.
So that's that.
Can I have a quick question?
Yes.
What's the difference between the WAF, APM, and a firewall on F5?
That's a nice question. But again, it's a out of the box question, right? That we are eating lunch in, right? Okay,
Hmm.
so let me tell you. So this APM, right, Access Policy Manager, it's kind of I would say that you have got some internal applications or whatever applications that you have got. So you want to provide the controlled access of that application to your end users. It's kind of remote access VPN, right? It's
Okay.
kind of remote access VPN. So that's what APM does. So you can provide your application access to your users with you know with some sort of policies applied with that, right? And
Right,
then
so create that external.
ASM is WAF, Web Application Firewall.
Mm.
So it's a WAF solution. So when I say WAF, Web Application Firewall, which means that uh, it will be after your LTM load balancer, but before your backend servers, the real servers, so that you can prevent your backend servers against DOS attacks, the DDoS attacks, as well as SQL injection, and there are many different types of attacks that could happen on your backend servers, right? Or maybe on your database servers. So just to prevent your database servers or your application servers against the attacks, you always deploy the WAF right before that. And remember that WAF is not a solution which is given by the F5 only. There are so many WAF providers out there in the market, right? So you can see WAF services are provided by F5. The WAF is also provided by FortiGate. The WAF is also provided by the Sophos. The WAF is also provided by like many others as well. So the web
I-MEDITA
application
also have a
firewall.
training on the APM apart
No,
from
we do
LTM.
not. No, we do not. So we do not provide training. As of today, we are delivering training on LTM and GTM only. We are not delivering training for ASM, which is WAF. Also, we are not delivering training for APM, right? So we are not delivering those two trainings as of today. We are delivering training only on the LTM and the DNS as of today, right? Like see, even if in future if we are going to start the ASM and APM, it's me only who will be preparing or who will be delivering that training. I have working experience over the ASM and the the APM, but point is that like we do not get that many people inquiring for those trainings. Ideally people are focusing more on LTM and DNS, and then I mean that's what we get actually as a business, right?
Yeah, currently we are hiring, so we are not getting a candidate. So that is the reason we have started preparing.
And that is a true statement that you would get. You might find people having LTM skill set or DNS skill set. LTM is normal. DNS is not that easy. But then on top of that, ASM and APM, those are something like it's like a very, very difficult to find a people having those skills. Very, very difficult.
Yep.
First, there are multiple reasons behind that. Why? Because you do not deploy the ASM, which is WAF. You do not deploy WAF everywhere, right? You don't. But like being a customer, I don't really care sometimes about the WAF, right? And same goes with APM, right? Because APM is also not that popular product. So it depends. Like the having skilled people in the market is always depending upon that how popular your technology is. Like Cisco is much popular, right, among all of them. Nowadays AWS is becoming popular, and in similar way you are getting the AWS resources because people are getting trained and more trained on this AWS technology and Azure technology. I would say in nutshell cloud technology. So you can easily find the cloud resources. Same goes with Cisco networking resources, right? Because that is more famous. People are getting more trained on that famous technology because as an engineer, I would think, okay, I get more opportunities with Cisco technology, then I should learn the Cisco technology. So that's a mindset being an engineer, right? So because the ASM is not that popular, the WAF is not that popular, and that's the reason that you would get very less amount of skilled people with those technologies. So that's the reason. Well,
Yeah.
that's that. So I hope that now everyone has understood uh, the requirement of covering the basics. When I say basics, which means like TCP connection, three-way handshake, the SSL connection negotiation, right? So all those sort of things. Like everyone must have understood the importance of that before we proceed further with the LTM thing. So as I mentioned before, that we're gonna cover the basics first. So I'm not saying that I'm gonna cover the 101 fully separately. No, I will cover whatever is really important for you as as a F5 LTM engineer. I'm not going to cover everything. Okay, all right.
Here you
Yes,
use a word that it acts as a proxy. Is it act as a proxy server,
yes,
which is a system that provides gateway between users and the internet,
yes,
which
yes.
prevents cyber attacks from entering a
Yeah,
private network,
yeah,
kind of thing,
absolutely.
right?
Yes, it
So,
is.
so
But
uh,
that the
yeah.
proxy server that you are talking about is a forward proxy, right? Like
Oh,
ideally you can make I don't know about the Microsoft server, but I have heard somewhere, I didn't work on that, but I have heard that even the Microsoft server can be configured as a proxy server, right? And apart from that, ideally the Cisco WSA, right, web security appliance, also known as iron port, right?
okay.
So that is famous as a forward proxy. Then your Zscaler is also forward proxy, which is a cloud-based proxy. Then Cisco Umbrella is also a proxy, which is forward proxy, but again cloud-based proxy. That is given by Cisco and Zscaler respectively as a SaaS based on SaaS models, right? And also they are calling it SASE nowadays. Then Palo Alto Prisma is out there, right? And then even the Palo Alto firewall has got itself a functionality or feature called the forward proxy. And in fact, Palo Alto also claims that even the firewall itself can also act as a reverse proxy, like they have got some sort of features. And apart from that, then you have got Blue Card proxy, right, which was so much famous from the Symantec side, right? So that is also an example of the forward proxy. So I'm not sure that which proxy you're talking about here, because as a part of forward proxy, we have got so many different options available out there in the market.
One question is also in my mind regarding load balancer. Yes, so far as I understand about this load balancing, that it is load balancing between the servers requests, right? Uh, is it possible to load the balances of the routers where some
Absolutely.
ports have some
That
higher
for that
than
we have got
traffic?
a concept called link load balancers. So if you have got like multiple links, let's say you have got the multiple internet links and you want to perform load balancing among them, you can also do
Yes,
that, right? So that is called a link load balancer, right?
right, right,
So
right, right,
so
right.
that also can be done, right?
Okay, thank you.
And yeah, we are calling it a proxy. Why? Because you are terminating your connection on this big IP, right?
Mhm.
You are terminating your connection on big IP. So on behalf of the real backend server, like when I hit f5.com, does it mean that I'm hitting directly F5 app server? No, I'm not.
No,
I
no.
am hitting to a reverse proxy in between. They must have deployed the load balancer and they must have deployed their own load balancers actually, right? So they must have deployed their own load balancers right before their application server. And that load balancer must be, must perform the load balancing between the application servers, which are hosted in backend. So we are not directly establishing connection from my laptop to the F5 application server. No, it should be their load balancer. So basically, we are terminating on their load balancer. So we are making the connection with that load balancer, and that's why you are calling it proxy, because F5 load balancer is working as a proxy. It is not allowing you to go to backend server, the real backend server, to establish the connection. So that's the reason that you will call it proxy. Proxy means that you are trying to do something on some other behalf, right? You're trying
So
to perform, or you
leak
are.
load balance, can we make this F5 leak load balance
Yes, we
also?
can. We can.
Fine, fine,
Yeah,
fine.
we can.
Is it possible to do this thing here in upcoming
You
sessions?
can't cover everything, right, Gurpreet? You
Uh,
can't cover everything, but yes, I will try my best to answer your all questions
Thank you
and
so
to
much. Thank
cover
you so
to
much. Thank
cover
you so much.
to cover as much as I can. But
It's
I
all
would
of your
also have
goodness.
my boundaries, right?
Yeah, 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 yeah. It's all of your goodness. Thank you so much.
Okay,
Thank you so much.
so that's LTM, right? Fine. Let's get started with some sort of basics now, right? I mean,
Um,
especially with Mandar. Yes.
yeah, sorry. I have a question regarding the certification exams. To be very specific about 201 and 301 AB exams, do we get kind of a simulations in these exams, or it's just an option, selecting the answer, that kind of an exam?
Yeah, I mean, these all are the multiple choice based questions that you would get during your exam. So there
I
will
mean
be a
to say,
question.
what I mean to say, what I mean by simulation is kind of, we get to configure or troubleshoot some
No, you
scenarios.
don't do that. You don't do that.
Okay.
Especially with 101, 201, 301, A and B, you don't get that. You only get the questions with the multiple choices and you have to select the correct choice.
Yeah. Hi, Saurabh.
Yes, Aman, tell me.
Yeah. Actually, I just want to clarify that as you are talking about the link load balancer, as it is the same as the FHRP in the Cisco, like GLBP, VRRP, and HSRP, the same actually functionality of the both are same according
Yes, in some in at
to
some
load balance the
extent,
ISP link. As you
at
have said, now we have to
at
load balance the
at
ISP
some
link. That we
extent, at some extent, yes, you're right. At some extent, not
okay.
exactly 100%, but yes.
Okay. So can you please explain in brief what is the difference?
right? Let's
Okay.
not talk about the link load balancer over here, right? I mean, that's let's not start from there, right? I mean,
Okay,
let's
sure, sure,
be,
sure.
I mean, first we need to understand the big IP, right? I
Okay,
mean,
sure.
let's not directly drag into the LTM kind of thing, the load balancing thing, and that too into the link load balancer, right? I mean, we're not talking about the load balancing between the servers. We are talking about the load balancing between the ISP links, right?
Yeah, yeah,
So I mean, now how you have deployed the HSRP or VRRP or
yeah,
GLBP, that depends upon like how you have construct your topology, you know. Uh, and then, as I said, like depends like where you are utilizing that VRRP. So again, I will not take that example now. Why? Because that is gonna take so much of time, right? Because see, you're gonna start VRRP from the lane side, and then you will deploy the VRRP towards the WAN side,
yeah,
right? Ideally, we deploying VRRP towards the WAN side is not that normal, is not that popular thing that you are mentioning.
yeah.
But yes, that can be usable. You can use that to perform
Okay,
the link load balancing. I mean, when it comes to the VRRP and sort of things. Well,
okay.
now I will come back here, right? And then let's talk about the 101 a little, right? So for 101, I have one guide with me, and then I can take the reference from that, right? So that we can cover it a little quickly, because I don't want to spend a whole lot of time on the basic stuff, right? Come on. So 101 is all about the application delivery, right? So if you look at, again, it has been divided into multiple sections like OSI model, and then the solutions and technology, and then load balancing, essentials, like which all different load balancing algorithms are supported, and then security topics like what is positive security, contrast, or what is negative security model, right? Or you can call it like contrast. Then cryptographic services, the advantage of authentication, then the purpose, advantage, and use cases of the IPsec and SSL VPN. Although you're not going to configure them here, but it's just talk about those VPNs so that we are familiar with those terminologies, right? And then the platform, like which all different types of platform we have got, right? So like in total, we have got 5 sections. Now, this 101 is a little old with me. So for now, if you want to go through a latest one, then I would go back to the 101, right? And then you go to study material to ask F5. So that's the support dot like myf5.com, and then manages, right? So that's the my.f5.com, and you get a lot of resources available on this my.fi.com, right? So they have recently renamed that domain like myfi.com. Earlier it was like a little different, right? I will also cover that thing, like which all different support domains we have got and how we can utilize them. But for now, let's talk about the 101 application delivery fundamentals. So if you go there, right? So this is the exam summary, like you're gonna get the MQC, right? So MQC based questions during the 101. So you should have the understanding of IP network fundamentals, the protocol. So this is what I have told you, right? The basic security concepts, the common traffic management concept. The MQC should also be familiar with the 5 technologies: the application delivery, networking, traffic distribution, which is load balancing, right? And be able to identify common problems and likely causes, right? So you should know about a little about the TMOS. I mean, it's not much, but a little about the TMOS, right? Then you must be knowing about the OSI model, the device logging, troubleshooting the basic network connectivity issues, create a problem statement, understand client server networking, because that's what TCP works based on, right? So TCP works based upon this client server understanding. Then HTTP error codes, we need to know about their meanings as well, right? Then basic difference between public and private cloud, and then the application service ports, right? Like obviously for HTTP, HTTPS, FTP, TFTP, SFTP, and all those kind of applications, right? DNS, DSCP, and so this is about the exam summary, right? Now, if you go back to the blueprint for 101, there you go, right? So This is the blueprint of 101, the latest 101, because F5 has also changed their certification a little, right? I mean, they have recently they changed, they made some changes to their content, right? But still, it is same, like some minor changes, some minor changes have been made. A couple of things were removed and couple of more things were added to the certification, right? Now look at the section 1, right? So they're talking about the VLANs, they're talking about the switch router, right? Application, the requirement for application connectivity, right? So you should be knowing that, okay, what is the function of router, a firewall, a switch, right? And then you should be able to interpret network diagrams, right? And then what about the IP addresses like private IP, public IP, multicast IP addresses, the broadcast addresses, subnetting, right? What is NAT, network address translation? What is DHCP? And then obviously you should have some sort of knowledge around the IPv6 as well. Then state the service that ARP provides, right? I mean, then you should be knowing about the ARP. Now remember that ARP protocol is not applicable for IPv6. So for IPv6 you get NDP, Neighbor Discovery Protocol, right? So you should be aware that ARP is not applicable for IPv6. So sometimes you might get questions around that. And then scenario established required routing, right? So why routing is needed, what is network hop, and that you can understand by using the traceroute command, or maybe sometimes you can use the ping command. There we have got a couple of commands that we could use to test the network connectivity, right? And all that kind of stuff. Then we are then 1.06 is all about the ADC application objects, like what is application delivery controllers and the benefits of the application delivery controllers, and why should we use the load balancer. So when we say application delivery controller, ADC, which means we are talking about the load balancers here, right? The section 2 is about troubleshooting, like how many different types of HTTP error codes we have got. So like I will be taking some generic examples and will be explaining that to you, and the possible reasons why you might get those, connection termination, identify possible causes for failure to establish the connection itself, right? Then ARP again, and then traffic is arriving at the destination, like how we can identify that. Then layer one connectivity will be depending upon your physical connections, right? The Ethernet panel, imbalance link, then interface bandwidth, how to check that, how to check duplex settings, right? Cable out of a specification, so how to validate all that kind of things. Then obviously you have got the maintenance, and in maintenance you have got like what is traffic object statistics. Like for example, if you have created a pool or pool member, or maybe a virtual server, so how you can get the statistics of that configured object on your big IP, right? And then how to upgrade a device, like how to upgrade a software, right? And when to upgrade a platform itself, right? So ideally you would be upgrading software, but sometimes you may have to upgrade the platform itself. So you need to know that in which circumstances you may have to upgrade the platform itself, and where you would be upgrading the software. So upgrading software is part of the day-to-day activities ideally in production environment. But yeah, then you should be knowing that which all steps you should take to minimize the downtime during the maintenance, right? The traffic flow, right? Explain application client server communication, and then SNMP, then interpret service status, like compare active versus inactive ADC elements, like how you can see or how you can determine that which all components are up, which all components are down, right? So that's something that you should be knowing. Then QKVU, like what is QKVU, and then how you can check for disk space, CPU utilization, the memory utilization, the bandwidth utilization of the interfaces. And then you also have got the ICMP protocol itself, because ping and trace route, these two utilities, right? These two utilities will be using ICMP in background. So it is essential for each one of you to understand the function of ICMP, and of course the OSI model, the function of TLS, and the function of VPN, and then of course the high availability, right? And then finally we have got some sort of some basic protocols such as DNS, NTP, syslog, SNMP, because these things are very important while configuring a hardware device, right? when it comes to the configuring DNS. Because see, if DNS is not configured on your big IP, then it will not be possible for your big IP to talk to the internet. If the NTP is not configured, then time will not get synchronized. If syslog is not configured, then your log messages will not be. These all are the components that you need to talk about before taking this exam. The cost of this exam is $180 plus 18% GST. The duration of the exam would be of 90 minutes, and the passing score. Any questions?
Yes, yes.
Go ahead.
Basically, before of it, there would be a basics of LTM in which it covers clone pools and multi-clustering
Mm-hmm.
and other things. You are directly come on 101, but before of it, there would be a basics of local traffic management, which include node availability, gateway pools,
So I'm not
filtering
covering the
mechanism.
LTM. Who said that I'm covering here LTM? I'm not talking about the LTM.
Okay, okay. Basically, you are just telling the 101 covers these kinds of content, but before of it, there would be a basics of the local traffic management in which it covers call
I mean,
pools,
see, there are so
cluster.
many things that I could discuss with you, Gurpreet, right? There are so many things before we begin with this. But at the end of the day, we need to see that what is relevant for us, right? And the F5 course has been designed accordingly. So for you to start with the F5 Big IP, these are the essential things, right? Especially, I'm not going to cover each and everything here, right? I mean, each and every line from which is specified there, right? Because as I mentioned in the beginning, I'm not going to cover 101 separately. I'll take some topics out of it. I will explain
No,
it
no,
to
no,
you
no.
so that you are
One
comfortable with
minute,
that.
1 minute, 1 minute. About clustered multiprocessing, it is a start of this F5, which should be covered,
No, it's
right?
Gurpreet. It is in
One
your
minute,
opinion. It is in your
1 minute.
opinion, not in my
Yeah, yeah,
opinion, because
yeah.
clustering of server is not part of the F5 training. How can I explain you the Microsoft clustering? Just think about it.
No, 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 no. I'm not asking
No,
about the
I mean, Gurpreet might be,
no.
Gurpreet, I think you are referring to TMC component, right? CMC clustering, clustered multiprocessing, TMSH and
Which
all,
of
right?
this? Who are you there?
HHC,
Your name,
I'm
please.
Sanjay here.
Yeah,
I'm
Sanjay.
Sanjay here.
Sanjay,
Yeah,
basically, I have a book for the big IP, local traffic management, in which basics are defined clearly that in what is virtual servers, how to create a virtual server, what is multiple wildcard servers, and then after cluster multiprocessing is what clone pools are what, and then after it is very little topics and TCP request queue, load balancing methods, priority based member activations, ratio weights, health
Then you are
monitors.
not understanding me, Gurpreet, here. What I have
Yeah,
said is before.
I
No,
can
no, 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 no.
understand you.
You are
I
not.
can understand you.
If you were
No, 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 no.
understanding me, you
I can
hold on,
understand
hold
you.
on, hold on,
You are giving a training of F5. That's fine.
hold on, hold on. Gurpreet,
In fact,
can you
yeah,
hold on for a minute? Yeah.
yeah.
Okay. Let me tell you one thing here clearly. Before starting the F5 LTM training, I'm giving you the training on the basic components. Now, if you don't want me to discuss about the basic component, that is fine, absolutely fine. I can directly start with the F5 LTM where I will discuss about the virtual server, what is node, what is pool, what is pool member, how does it work. I can directly start with that, which the book you are referencing that starts with the LTM training.
Okay.
and that's what I'm also saying. It is basics, right? So we haven't even started LTM.
So
Okay, okay.
don't worry about that. You will
I
be
clearly,
covering, I will be covering those all components once we start with the big IP LTM. You don't need to worry
but
about that. But
yeah.
before
But
we start,
straightforwardly,
hold
I'm
on,
not an expert.
hold
I'm
on.
not expert in F5. I need
Uh,
some kind of basics
uh,
knowledge
see,
before to
see,
do
see,
some
see, see.
experiment.
And that's what I am trying to cover here. I'm not
Okay,
even
okay.
expecting you to be expert in HTTP. I'm not expecting you to be expert in TCP three-way handshaking. That's the
Right.
reason that I'm starting from here. Else I would have started with the big IP LTM directly.
Okay, fine.
So when you say that you are reading that book which is covering F5 LTM, I understand fully that okay, they will start with the different types of virtual servers. They will start with the nodes and node status, the pool member status. Those are the very basic thing of the F5 LTM, right? But as I mentioned, I'm not starting directly with F5 LTM. If I would have started with the F5 LTM, obviously today itself I must have started with that terminology called virtual server, the pool or pool member, and all that kind of stuff. I am even starting before that, from the level of before that, before LTM, tiny things, right?
Oh, great,
So
great.
you can understand the functionality of the virtual server if you understand the functionality of the TCP. So understanding TCP is more important than understanding the virtual server in the beginning.
Right.
Understanding the HTTP is more important than than before understanding the pool or pool member or whatsoever. Let's not talk about the F5 initially. Let's talk about the generic terminology. Like what do we understand from TCP? What do we understand from HTTP? Let's forget about the F5 at all. Let's not talk about the F5 for next maybe today and tomorrow and then even for the next weekend. Let's not talk about the F5 at all.
Right. Thank you. Agreed.
And by the way, where do you work, Gurpreet? In which company you are? I'm sorry, I forgot that. I believe you
Uh,
told me.
sorry. I don't want to disclose here. Sorry
Oh,
for that.
okay. You can ping me one-on-one if you could.
Oh, sure.
So fine. We have had enough discussion that what all sort of things we are going to cover during this training. So the next thing that I would cover is, like let's get started with the TCP connection, right? And that's so easy for us to understand. Like I can do one thing. For make you understand about the TCP functionality, right? Or maybe I would say the OSI model or TCP IP model, right? I will start using this book, right? Probably I can share it with you as well so that you can also read about it. It's very basic. And I'm expecting all of you to be familiar with this one, with all these topics that I am going through now, because this is OSI model and even I'm not supposed to cover it, but I'll just give you a brief idea about it and then I will talk about the protocols, right? So OSI model has got like 7 layers, each one of you, and obviously are expected, right, to have this background knowledge like application layer, presentations, session layer, transport layer, network layer, data link layer, and then physical layer. So the sender will always start from the application layer. That's what we need to understand, right? The sender will always get started from the application layer, and and then recipient, whenever recipient receives your data, that is going to start processing your data starting from the physical layer, right? So we just have to understand the processing of the layers, right, from a end user perspective. So if there is a sender, that would always start from the application layer. If there is a receiver, that would always start processing your data from the physical layer, right? So that's that. So we have got like presentation layer, the session layer, the transport layer, and then we have got like all these layers. I'm not going to cover each one of them now independently. Let's talk about the data link layer directly. I'm not talking about the physical layer, because physical layer would cover your different types of cables, and that's not something that I should cover here, right? So let's talk about the data link layer. At data link layer, you must understand what is VLAN, right? Virtual local area networks, right? What is the VLAN? Then what is layer 2 ether channel? Then what is layer 2 forwarding? Like how data is forwarded based on the layer 2 information, which is your basically MAC address, right? So even you don't really have to understand the big IP for this. We don't really have to talk about the big IP a lot. We just have to talk about a layer 2 switch, let's say, right? So you have got a layer 2 switch, and now let's say frame was received by a switch, right? On its one of the ingress interface, like let's say 0 by 1 was the ingress interface, frame came in. Once frame was came in, it is always going to read its source and destination MAC address. And each one of you would agree to that, right? That whenever frame is arrived on a switch, the switch is going to read its source and destination MAC address, right? The source MAC, and then we have got the destination MAC addresses. So if we talk about the source MAC address, having the source MAC address as part of the MAC address table, right? Obviously, source MAC address would not help the switch to forward this frame which has been received, But keeping that source MAC address entry in its MAC address table would help if you are receiving the data for the MAC address which is connected on this interface itself, right? So for example, if somebody else is sending data for this MAC address, then having that MAC address in its MAC address table would help this switch to perform the unicasting. Because see, if you talk about the layer 2 forwarding, at layer 2, there are two terminologies that you use in most cases, the unicasting and then flooding. So you need to understand that what is the difference in between unicasting and flooding at layer 2. If destination MAC address was found in the MAC address table, it will always perform unicasting. If destination MAC address was not found in the MAC address table of the switch, then it will always perform the flooding. And what is the flooding? I don't really, I'm expecting that all of you are familiar with that flooding keyword, right? So it's kind of broadcasting, like switch will send a copy of the received frame out of its all active, active interfaces, right? So that's what flooding is. So the switch will perform flooding. And in case if destination MAC address was not available in the MAC address table, right? But in case if MAC address was available, then it will simply perform the unicasting, right? So your Ethernet MAC address will be used for the data forwarding at layer 2, right? At data link layer. So having knowledge around the MAC addresses is very important. And the ARP protocol is also a layer 2 protocol. Now there are some people who says that, okay, no, ARP is a layer 3 protocol, and it works at a network layer and so, right? And some people would even try to prove that. But even in my opinion, it is a layer 2 protocol. F5 says it is layer 2 protocol. Even Cisco says it is a layer 2 protocol. But there are many people around the world who says that no, ARP is a layer 3 protocol. But I would say that it is a layer 2 protocol. Why? Because it works based on layer 2 information only. And when I say layer 2 information only, which means that it does not get encapsulated at layer 3. Since it is not getting encapsulated at layer 3, which is IP, IP layer or IP header will not ever encapsulate the ARP payload. So we can't call it layer 3 protocol. We always going to call it layer 2. Why? Only Ethernet will encapsulate your ARP payload. Now, what is ARP payload? That we will discuss later on, right? But if you talk about the MAC addresses, we need to understand that MAC addresses have got 48 bits, which means 6 bytes. Right. And also you can see that MAC addresses are further divided like vendor assigned, the or OUI. I don't want to move into that kind of thing that, okay, what is OUI or what is vendor assigned? All you need to understand is that at layer 2, we have got the concept of the MAC address for the Ethernet technology. Remember that at layer 2, if you are using the Ethernet technology, then only there is a use case of the MAC address. There is a use case of MAC address. If you are not using Ethernet at layer 2, let's say you are using frame relay, which is again a layer 2 technology, right? Or maybe you are using ATM. So for frame relay or maybe ATM, frame relay, right? We do not use the MAC addresses. Over there at layer 2, we will be using some other addressing schema or addressing mechanism, right? But for Ethernet, we will always use the MAC addresses. So MAC addresses will always be in role whenever you are working on the Ethernet technology at layer 2. Remember, the MAC addresses will always be represented in the hexadecimal format, right? You have got in total 48 bits. Since you have got 48 bits, and you know that in hexadecimal, one character is equals to 4 bits into the binary. So since you have got 48 bits, which means you would have in total 12 characters in your MAC address. In total, 12 characters will be there. Out of 12, first 6 characters, right? And the next 6 characters. Next 6 characters will define vendor assigned, and first 6 characters will define your OUI, organizational unique identifier. Right? So this is how the MAC address is divided into 2 parts. Now, we don't really have to worry about it because ideally, as a load balancing engineer, we don't really have to focus on it, but we just have to know about that. Okay, what is MAC address and how does it, how do we represent that? So representing MAC address is always going to happen in the format of IP, in the format of hexadecimal number system, right? Then at layer 2 itself, we have got a terminology called broadcast domain, right? So you know that a broadcast domain is going to be a collection of those devices where one device is sending a copy of the frame and others are receiving, you know, like if one device is sending a broadcasted frame, then others are receiving, all devices are receiving a copy of that broadcasted frame. And that collection of devices will be called a single broadcast domain, right? So I'm repeating my statement. A single broadcast domain is a collection of devices where if one device sends a broadcasted frame, then others will always receive a copy of that broadcasted frame. Now remember that global layer 2 broadcast address is always going to be all F in the MAC address. So if you see all F in the Ethernet header as part of the destination MAC address, that would be considered as a broadcasted or global broadcasted address, and that would also be considered as a broadcasted frame, right? So whenever a switch receives a frame whose destination MAC address is all F, that all F will indicate that it is a broadcasted MAC address, and then switch will always perform the flooding for that, which means that switch will, if switch receives, let's say there was a switch, right? It received a broadcasted frame here, then it will send a copy of it to all. Even if repeater is receiving a broadcasted frame here, it is going to provide a copy of that frame to all these machines, which means one is sender, then all others will be receiving a copy of that. That group of devices will be known as a single broadcast domain. Now you can divide that by putting a router in place, but also I mean, you have divided broadcast domain by placing a router, but also you could divide that by the help of VLANs. So that's the use case of the VLAN. So the use case of the VLAN would be to break a larger broadcast domain into some smaller broadcast domains. So how you can define that? Okay, you would be needing a different VLAN now, or maybe you need to divide your broadcast domain into multiple broadcast domains by the help of VLANs, or where would you think that okay, you need a VLAN, right? So if you have got more than 200 devices on your local area network, then we recommend you to break that larger broadcast domain into multiple smaller broadcast domain by leveraging the VLANs. The second, if you have got a lot of broadcast traffic, the layer 2 broadcast traffic in your local area network, then also you should break your local area network into multiple virtual local area networks by the help of VLANs. In case if you have got a group of users who require more security, right? Then again, you can use the VLANs, a dedicated VLAN for that group of users, right? A group of users needs to be on same broadcast domain because they are running the same applications, right? I mean, if they are running the same application like VoIP phones, right? So they are running same applications, so obviously they should be on a same VLAN. But then users using the phone could be on different VLAN, right? Not with the regular users. Like ideally nowadays, you would see that you would have one SSID in your organization called for BYOD, bring your own device. Then other SSID would be for like this would be for employee BYOD, right? Employee BYOD. One SSID is for them. The other SSID could be for guest. Then third could be for your corporate machines, right? Corporate users. So ideally, you would get these three SSIDs nowadays in all of the organizations, right? Across all organizations. So in that case, you have got like three different VLANs for them. So like maybe you are using VLAN 10 for BYOD, for guest you are using VLAN 20, for corporate users you are using VLAN 30, right? So like for different types of users or for different applications, you can have different VLANs. Now remember that by default, no traffic, whether it is a broadcasted or unicasted. Point is that no traffic will ever go from one VLAN to another VLAN from a networking perspective. Okay, you should be knowing that by default, no traffic can move from one VLAN to another VLAN. And same goes on F5 BIG-IP, right? So if you are working on F5 BIG-IP, let's say, and you have created like two separate VLANs. Let's say you have created VLAN 10, you have created VLAN 20. By default, traffic will not move from one VLAN to another VLAN until you perform the inter-VLAN routing, also known as IVR. Now, inter-VLAN routing can be performed using Cisco routers, layer 3 switches, Juniper routers, Juniper layer 3 switches, right? And also it can be performed by F5 load balancers. Remember that F5 load balancer can also work as a routing device. That is quite interesting because ideally we say that, okay, it is a reverse proxy, but since it is a layer 7 device, that means that it can also work at layer 3, because when we talk about the routing devices, these all devices are the layer 3 devices, right? So at same time, the BIG-IP can also work as a as a layer 3 device, right? Which means that you can even perform the routing using the BIG-IP, and we will see that how we can utilize the BIG-IP as a routing device, because it is need of our right, or need of the production environment. Sometimes you would see that in production we would have the BIG-IPs configured as a routing device for a couple of VLANs, right? So we would see that how we can do that, right? So that's where the VLANs will come into the picture, and then inter-VLAN routing will also come into the picture. Now, the question is that why don't we just perform subnetting? Why are we using different VLANs? So the question, or the simple answer would be, let's say there is a switch, right? A layer 2 switch. And there are some group of users. There are two group of users belongs to two separate departments, connected on 0 by 1, 0 by 2, 0 by 3, and then 0 by 4. So we have got like these 4 different interfaces. And let's say here we are using 10.1.0/24, and here we are using a different subnet, 10.1.2.0/24. So these two are different IP subnets. I'm just giving the answer of this question. Why not just subnet your network, right? I'm trying to give you the answer for that question. So let's say we are using different subnets at both ends for both departments, but this switch is a layer 2 switch. And then further you are connected with, and you are using the same VLAN, unfortunately, that you should not be using, but let's assume that we are having a common VLAN. If you are having a common VLAN, then you would see that whenever this host A is talking to host B, let's say, so first it might require to send some sort of ARP request to obtain the MAC address of host B, right? I mean, the MAC, obviously you would have the IP address of host B, but you would not have the MAC address in the beginning. So you would send a ARP request. ARP request is broadcasted. So once this broadcasted frame is received by switch 2, then it is going to provide a copy of that broadcasted ARP message to host B, but not only host B, but also to everyone else. Although they are using an IP address from the different subnet, but this layer 2 switch doesn't know about that, right? This doesn't have visibility to the IP addresses of these host machines. If switch doesn't have the visibility to these host machines, then obviously, like when I say visibility of the IP address of these host machines, since it is a layer 2 switch, right? Although it has the visibility that, okay, there is a device connected on this port, and even it will have the MAC address of these machines in its MAC address table. But whenever it has received a broadcasted frame, it will simply perform the flooding. While performing flooding, a copy of that frame will be given to all. So now you could see that the data from one department is going to the another department, right? Your ARP messages are exposed to all. So even doing just subnetting is not a solution. So if you're doing subnetting, fine, you are using different IP subnets for different departments, but at the same time, you must use the different VLAN for them. Does that make sense to all of you, or how is it? That's VLAN, right? And then how we can enable the inter-VLAN routing, that again, I'm not performing it using practical now. I'm assuming that all of you are aware with that how do we perform the inter-VLAN routing. We will be doing it on BIG-IP, don't worry, right? Because I'm expecting that you are already aware that how do we perform the inter-VLAN routing using Cisco layer 3 switches or maybe routers, but we will be doing that using BIG-IP, because BIG-IP we're going to start from the scratch, right? Then next is like, what is link aggregation? And this is very important topic when it comes to the BIG-IP as well. Why? Because sometimes, or not sometimes, I would say that for the purpose of redundancy, in most cases, you would see that we are, we are doing this kind of link aggregation between the switch and BIG-IP systems in our data centers. And I'm not only thinking from a switch perspective, like a generic switch perspective. It could be a Nexus switch. You might, like in most cases, you would find Nexus switches installed in the data centers, correct? And they must be running with the VPC. Do you all agree with that? That in most cases, we find Nexus switches in data centers and then VPC is enabled there, right? Between the Nexus switches. So if Nexus switches are running with VPC, and then let's say you have got a BIG-IP, that's a BIG-IP, right? And it has got 4 interfaces, and you have got Nexus switch 1, and then you have got a Nexus switch 2, which are running the VPC. Then you will take like 2 links to switch 1 and then remaining 2 links to the switch 2, and then you will implement the VPC. So Ether channel is very important, right? And now this way you also get the redundancy here, right? I mean, if one of the core Nexus switch goes down here, where VPC is running, still there is no impact, or maybe, you know, the cable becomes faulty, still there will not be impact on the reachability of this big IP. So multi-chassis Ether channel is supported, right? When you configure the VPC. Or maybe if you are using, if you are not using Nexus and you are, you know, you are using the Catalyst, then there is a concept called VSS for the multi-chassis Ether channel. So yes, you could use that, right? So I mean, Ether channel is very important. So remember that here, some big IP platform will support only static Ether channel, some of them, right? And most of them will support the LSCP, not PAGP. Remember that PAGP is not supported at all. Now what is LSCP? Link Aggregation Control Protocol, right? Which is an open source protocol that we use to perform link bundling, right? Because in LSCP, both devices will negotiate with each other, right? If they have got like the common properties at both ends, then only the link will start participating in your, Ether channel, right? Or port channel, right? If the properties are not matching at both ends, then that link will not be participating in your port channel, right? It will not participate actively. So LACP will do that on your behalf, because if you are using the static Ether channel, then you go and bundle at both ends, no matter whether their properties are matching or not. And then your data, the actual data might start getting dropped, right? So if you don't want your device, I mean, you don't fall into that kind of issues that, okay, you did the manual or static Ether channel configuration, but the parameters were not matching, and now user data is being dropped by the malfunctioning of the Ether channel, right? So better that we use the dynamic protocol if it is supported. And as I mentioned, that there are very few platforms which will support only static Ether channel, but most of them are going to support the LACP. So you should use the LACP, because LACP would perform the negotiation, and negotiation is very important, because during negotiation the devices can easily compare their compatibility, right? So if they are compatible, then only the links will start participating actively in the Ether channel, right? So LACP is going to be very important. And you would I mean, obviously the virtual, because in our lab we have got only virtual edition. Now in virtual edition you can implement Ether channel, but it will never come up. Like, obviously for Ether channel is not meant for the virtual edition, right? So you can make the configuration, but it will never come up. So I will show you that how you can configure it, but we will not be able to prove it that, okay, yes, it has came up now. But yes, in production we use it a lot.
So Big IP supports both L3 and L2 Ether channel?
No, it supports only L2 Ether channel.
Okay.
Right? So there is no point. Even let me tell you one more thing. You're talking about the Ether channel. Let's not talk about the Ether channel. Let's talk about the interface itself. On Big IP, you get only layer 2 interfaces. You can't directly allocate an IP address on the interfaces. That there is no way to do so. So all your interfaces, like it's a switch module that they have on Big IP, right? So these all are layer 2 interfaces. And then if you want to allocate IP, fine, create VLAN, put that interface into VLAN, and then allocate IP to your VLAN. That's how you allocate the IP addresses on your Big IP. Make sense? So you always have to create the SVI. So then, forget about the layer 3 Ether channel. It's so, I mean, because it has got layer 2 ports only. Okay, so LACP. Right now, I would recommend you, like, if someone is aware with LACP, that how does it work, fine. If not, then please, I mean, you can spend a couple of minutes over here on the LACP, right? So in LACP, you have got like active passive modes. So one end must be configured as active, the other end can be passive, but both ends must not be configured as passive, right? And it is an open source protocol, so that's a good thing about the LACP. And Big IP, in most cases, it supports the LACP, and yes, that's what is recommended as well. Then let's come back to the ARP protocol, right? ARP, address resolution protocol. That is very important. And in our day-to-day work, we are every day using. Even if you are working from home, and if you are not a network engineer, still you are using the ARP protocol. Your machine is using ARP protocol. Like, you can always check your ARP table on your machine. So let me tell you one thing. No matter that what device it is, it could be a F5 load balancer, it could be your laptop, your desktop, your cell phone, your Cisco router, Cisco layer 3 switch, the firewall, or a server, or whatsoever it is. I'll give you a condition. Like if it has got a Ethernet port, first the device should have the Ethernet port, because MAC address belongs to Ethernet ports only, right? Not to a frame relay or ATM sort of things. So if your device has got a Ethernet interface, one. Second, an IP address is configured on that. No matter what device it is, right? It could be HP router, HP switch. Vendor can be anything, right? Anyone, right? It could be Cisco, Juniper, HP, whatsoever. Point is that if your device has got Ethernet interface, and then an IP address is configured on top of that. So if IP address is allocated to your Ethernet interface, right? If an IP address is allocated on the Ethernet interface, right, then ARP table will be maintained by that device. The ARP will get activated for that device immediately. And also it is going to have a local ARP table. Like if I take an example of my laptop, right? So if I go to CMD, let me share my screen here for the command console. So if you are on this, command mode, then you could say ARP-A, and this output would display you the IP address and the MAC addresses that it has learned. So dynamic will display you, okay, that it has learned the MAC address of 1.1 and 1.8 dynamically. So type dynamic will indicate that I have learned that MAC address dynamically using ARP, right? So ARP is even running on your laptops, cell phones, and desktops. So in nutshell, I would say if your device has got an Ethernet interface, an IP address is allocated on that interface, then definitely it is going to have a ARP table. An ARP will get activated. Then ARP will work on the device. ARP is a layer 2 protocol, address resolution protocol, that helps a device to resolve a MAC address against an IP address. Like, for example, if you are trying to talk to one another machine, right? You are sitting on your laptop and then you are trying to ping some other laptop or desktop or whatever. You are trying to communicate with another machine. You always have to have the IP address of that destination host, right? That is mandatory. But we don't tell, or we don't get the MAC address of the destination machine, right? Having the MAC address of the destination machine is also mandatory as part of the OSI model or TCP/IP model, because layer 2 encapsulation is mandatory after layer 3. Once layer 3 encapsulation is done, then layer 2 encapsulation is mandatory, right? Like Ethernet header has to be attached onto your data. I will open up the, I will take the captures and then we'll explain to you that no data will ever be placed onto your physical media without having the encapsulation completed. So encapsulation is mandatory. Like layer 2 encapsulation is mandatory before placing any data onto your physical media, right? So having MAC address, destination MAC address is compulsory, but you never told or you never informed your machine about the destination MAC addresses, correct? So if you never...
One minute. Sorry for interruption. Could you please do it again? That what is the difference between static and dynamic ARP here?
These are the entries in ARP table. So static entries are those entries which are created dynamically, locally.
Okay.
Right. And like this is only for your, like if you look at here, it has got those entries for your broadcast IP address, right? And obviously for if you are broadcasting anything, then the destination MAC address will be all F, right? So it has created that entry, and it is a static entry. It has not learned it from anywhere else, right? It has created these entries locally. So if it has created some entries locally, then these are known as static. The dynamic entries will be those entries for which it followed the ARP process. Like it sent out the ARP request first, and then it got the ARP responses from those destination host machines, and that's how it learned the destination MAC address, right? So those entries will be known as the dynamic entries. So that's the only difference between them. All right. So point is that it is essential for you to learn the destination MAC address before forwarding data. Then only layer 2 encapsulation can get completed. Layer 2 encapsulation cannot get completed without having the MAC address of destination without learning the MAC address of the destination host. So it is essential, right? And for that purpose, you will be using ARP. I'll explain it, but by taking the captures, right? So I'll explain all these things which I'm discussing now while we perform the packet capture using Wireshark, right? And that I will perform tomorrow. Now, why VLAN is required, we already discussed about that. I don't have to talk about it again. So Ether channel, you saw that why Ether channel is mandatory, or is not mandatory. I would say is I would say important, because you get the redundancy between the devices, right? So if one of the physical link goes down, you still have the connectivity. So that's the reason that we get we configure the Ether channel between the switch and the big IP. And you would find it in most cases, especially in production environment. Okay, then layer 3. So whenever we talk about the OSI layer 3 or network layer, which means that we are talking about the IP addressing. That's about the network layer, right? You will talk about the IP addressing schema, right? That how many different types of IP addresses you have. You will talk about the network address translation. You will talk about the routers. You will talk about the layer 3 switches. You will talk about the routing as well. That's all about the network layer, because that's the functionality of the network layer, right? Or layer 3. So whenever we talk about the network layer or layer 3, we always talk about the IP addresses. So you must understand the IP addresses. Like we have got a total 5 classes, A, B, C, D, E, right? 5 classes. Then we don't use like class D and E addresses on our host machines. Why? Because class D is reserved for multicast routing. So only for the purpose of multicast routing, we use class D. The class E is also reserved for the experimental things for I mean, we can't use them, right? So only IP addresses that we have got usable, right, is class A, B, and C. So the IP addresses belongs to class A, B, and C. We can only utilize those IP addresses, right? And then we have got a whole range of IPv4 addresses. Out of that range, we have got again 2 further classes of IPv4 address, like private and public, and that's where the NAT comes into the picture as well, right? So I'm not talking about the NAT as of now, but you must be knowing that which all IP addresses we have got as a private IPs and which all IP addresses we have got as a public IP addresses, because that is very important for us to understand that which all IP addresses are private and public, right? However, before you go for the private and public, once again, you just look at that we have got class A, which we can utilize class A, B, and C. So if, like in IPv4, you get the 4 octets, I would say 4 blocks. The the range of each block could be in between 0 to 255. So the value of each block can be in decimals. The value of each block can be in between 0 to 255 only. Now the class of the address is defined based on the value of the first octet itself. So if the value of the first octet is somewhere in between 1 to 126, 1 to 126, because 127 is again reserved, then it is called class AIP. So you don't see the values of the remaining blocks, like the block number 2, 3, or 4. You just look at the value of the first block. So if the value of the first block of the IP address falls in between 1 to 126, then it will be called as a class A IP address. The class B IP address, if the value of the first block or first octet falls in between 128 to 191, then you will call it class B IP address. If the value of the first octet falls in between the range of 192 to 223, within that range, you will call it class C IP address. So that's how the classification of IPs has been made, right? There are predefined ranges. So just look at the first octet value, and then you can easily tell whether it belongs to class A, B, or. Now, out of this range, what they have done, they divided these class A, B, and C into 2 categories now, right? Which 2 categories? The public and private. So if you talk about the private IPs, right? The private IPs. Let me show you. Yeah, there you go. So if you talk about the private IP addresses, then we have got, come on, they have not defined that here in this PDF. Let me give you those examples here, right? So if you look at the private IPs, then out of this range, this entire range, right, we have got only 10.0.0.0 up to 10.255.255.255. These all are the private IPs from class A. Anyone can use them in your network, in my network, at my home, in your office. I am free to use those IP addresses. Remember, these IP addresses are also not routable over the internet because these are free to use, right? Anyone can use them. Then how come we can have them routable over the internet? So if you are using the private IP addresses, remember your traffic will not be allowed over the internet because private IPs are never routable over the internet. So out of this entire class A, we have got this specific range, which starts with 10. So if any IP address starts with 10, which will be considered as a private IP, right? Then and rest of them are public IP addresses, belongs to class A range of IPs. Now for class B again, because again we are saying that okay, if any IP address is first octet value, right? First octet value falls between 128 to 191. It will be a class B IP address. Now from class B, again, we have got a range for private IP address, and that's from 172.16.0.0 up to 172.31.255.255, right? That's a range of private IPs that we have got for private IPs. And that's we extracted this range or these IP addresses from class B. And again, from class C, we have extracted some private IP addresses. So from class C, we extracted this range 192.168.0.0 up to 192.168.255.255. So that range of IPs is private IP addresses. These all are private IPs. Anyone can use them in in their networks, but remember that these private IPs are not routable over the internet. So we need to be very careful while using IP addresses. That's what we are using. We are using private, we are using public, right? So we should be aware that what IP address is private, what IP address is public. And then the routing will also be done at layer 3. The subnetting, obviously, I'm not talking about the subnetting here because I'm expecting that all of you are a little familiar with the subnetting, but the routing is also done at network layer. Remember, all the devices, including your laptop, desktop, cell phone, the routers, layer 3 switches, the load balancers. Let's talk about the F5 BIG-IPs. Will always build routing table. And that is mandatory for these devices to have the routing table, because if a device like a router or maybe F5 BIG-IP receives an IP packet without having the destination IP in its routing table, it will not be possible for it to forward that packet. Now, in routing table, you can have default route, you can have a static route, normal, more specific routes, you can have directly connected routes. Even big IPs will support the dynamic routing. Now, if you are enabling dynamic routing, then you should be familiar with the dynamic routing protocols. When I say dynamic routing protocols, which means that we need to talk about the OSPF, EICRP, or maybe, BGP. So all those sort of protocols. So those are also supported routing protocols on the BIG-IP. Now, how to implement them? That is something that we will cover in the labs. That how to enable dynamic routing. Any questions from anyone?
Only two questions.
Mm-hmm.
First one is regarding IP addresses. As we all know that /32 is the highest IP address. Mostly and generally we are using for the loopback in our
Correct.
network. So /30 have only two IPs. Nowadays /31 is also come into picture. Yeah. So how could it possible to use /31, because it has not kind of network and broadcast address. So could you please highlight a little bit about this?
I see. That's a role of the operating system, right? So in those operating systems, they have excluded the concept of that network ID and broadcast ID. So even if you are using /31, so yeah, I mean, it will not consider anything like network ID or broadcast ID, because earlier the operating systems were developed in such a way that you were not able to allocate the network ID and the broadcast ID onto the interfaces of the devices. But now they have changed, they have modified the operating system, and that is the reason that the devices can accept those IP addresses. And even let me tell you one more thing. Not all devices are still supporting that. Like if you try to allocate /31 IP on your laptop, probably it will not support that. But
Okay.
it might possible that going forward, a new Windows operating system would come, and then it will also start supporting /31 IP, right?
Okay, fine. My second question is regarding the F5. You have said that F5 also a routing table.
Yes.
If it would be like that, and I think it should be management control and data plane of it also, right?
Obviously, it has got control plane and data plane both.
Okay, fine. That's it.
So if there is no specific route, F5 will follow a default route.
Obviously, and that's why you should have the default route, especially in case if you
Nah,
are deploying the application which is accessible through the internet.
internet. Okay. So one thing. So do we have any kind of WhatsApp group internal? I mean,
No, I
with
will
anyone?
create that. I
Okay,
will
great.
create that tomorrow, not today, right?
Okay,
I
great.
will gather all of your numbers and then I can create one. Yep.
Sure. Thank you so much.
Thank you. Okay. See you in evening, whoever is, is enrolled for the GTM. So we can have some question answer at evening. Okay. You should have received one link for the evening. As we discussed, आज हमें जो करना था वो था पैकेट फ्लो या TCP 3-way हैंडशेक, जो वो सब बातें की थी मैंने, VLAN ARP प्रोसेस एंड ऑल, वो सारी चीजें एक बार उसको प्रूव करके देख लेते हैं, ठीक है? छोटी छोटी चीजें हैं बट लाइक इम्पोर्टेंट वन। तो उसके लिए हम क्या करेंगे कि एक छोटा सा टोपोलॉजी कोई मैं ऑन करूंगा जिसमें हमारे पास कुछ एक दो एंड यूजर मशीन्स होंगी, राइट? और देन वी हैव गॉट ए स्विच, और इसमें हम TCP 3-way हैंडशेक या फिर जैसे UDP का बिहेवियर या फिर एनकैप्सुलेशन और डिकैप्सुलेशन, जो TCP IP मॉडल, उसकी बात करेंगे, ARP प्रोसेस की बात करेंगे, तो वो सब प्रूव करने वाले हैं। तो सबसे पहले ARP प्रोसेस को ही प्रूव करेंगे कि you always require a destination MAC address before sending traffic towards a destination IP address. तो जैसे इस विंडोज होस्ट का 10.1 IP रहेगा, सामने 10.2 रहेगा, राइट? तो एक होस्ट A से होस्ट B को हम पिंग करने का ट्राई करेंगे, राइट? और देखेंगे कि उसके बैकएंड में क्या प्रोसेस फॉलो हो रही है। ICMP का प्रोसेस भी देखेंगे और ARP प्रोसेस जो है वो भी देखेंगे। और ARP प्रोसेस एक वन टाइम प्रोसेस रहेगा, राइट? Once it has learned the destination MAC address through the ARP reply, तो उसके बाद वो ARP कैश में या ARP टेबल में किस तरीके से एंट्री क्रिएट करेगा वो भी देखेंगे हम। So let's get started with this Windows host now. तो ये सोर्स मशीन है हमारी, लेफ्ट वाली मशीन इस टोपोलॉजी में, और मैं इसका IP एड्रेस एक बार वैलिडेट कर लेता हूँ। IP config, अगर आप देखोगे सो 10 डॉट, अच्छा IP है नहीं, इसका ऑटोमेटिक पे किया हुआ है। सो लेट्स डू वन थिंग, इसको हम मैनुअली IP एड्रेस एलोकेट कर देते हैं। है तो so Windows was not ready. (10.1) डुप्लीकेट दिखा रहा है, ठीक है? जो एडिशनल डिवाइसेस हैं जिनकी मुझे जरूरत नहीं है उनको मैंने बंद कर दिया, क्योंकि इधर ही कहीं तो मैंने ये 10.1 पे करके रखा था किसी गेटवे के ऊपर, सो फाइन, अभी डुप्लीकेट नहीं दिखाएगा, तो आईपी कॉन्फ़िग दिखा देना चाहिए। एक बार इंटरफेस को डिसेबल और इनेबल कर देते हैं। अब देखिए आईपी कॉन्फ़िग मिल गया इसको, आईपी 10.1। अब जब आप आईपी देते हो ना किसी भी मशीन को, तो मैंने कल भी कहा था आपको कि हर एक होस्ट मशीन, जैसे लैपटॉप हो गया या फिर डेस्कटॉप हो गया, इनफैक्ट लेयर 3 स्विच, राउटर, फायरवॉल, लोड बैलेंसर, ये सभी डिवाइसेस एआरपी टेबल भी मेंटेन करते हैं। तो जैसे आपको ये मशीन पे ही देखना है, इस डेस्कटॉप के ऊपर देखना है, राइट? तो ARP-A ये कमांड रहेगी। तो इसमें 10.2 का मैक एड्रेस इसने ऑलरेडी लर्न किया हुआ है, अगर आप ध्यान से देखोगे तो, और डायनामिकली लर्न किया हुआ है इसने। ठीक है, हम क्या करते हैं, इसको डिलीट करेंगे, ARP-D से इसको डिलीट किया मैंने। तो ये कह रहा है रिक्वायर एलिविएशन, इसको नहीं मिला, तो वो देने के लिए हम इसको रन एज एडमिनिस्ट्रेटर करेंगे यहाँ पे। तो ARP-D से डिलीट किया, ARP-A से वापस देखिए अब आप। तो 10.100 जो हमारा गेटवे है, गेटवे का तो आईपी एड्रेस इसको मिल गया, बट 10.2 का आईपी एड्रेस नहीं, मैक एड्रेस, सॉरी, ARP टेबल में गेटवे का तो इसने ऐड कर लिया इमीडिएटली, बट 10.2 का नहीं है, एंड 10.2 इज दिस मशीन। ठीक है, और हम यहाँ पे gig 1/2 पे कैप्चर लगा लेते हैं, gig 1/2 के ऊपर कैप्चर लगाएंगे, एंड देन वी विल पिंग दैट मशीन। तो अब जब हम पिंग करेंगे, सो we will see that what is the background process now, what's happening in the background, right? तो remind me later, ये अपग्रेड नहीं करते हैं अभी फिलहाल, बाद में देख लेंगे। तो पिंग 10.2 कीजिए, कम बैक हियर, स्टॉप करते हैं इसको। अब इस प्रोसेस को समझने की कोशिश करेंगे। ये देखिए, जो फर्स्ट टाइम इसने किया वो क्या किया कि इसने एक ARP रिक्वेस्ट सेंड की है यहाँ पे। तो क्यों किया वो भी बता देता हूँ, क्योंकि जब हम इस मशीन पे थे हमने देखा कि 10.2 का मैक एड्रेस इसके ARP टेबल में नहीं था, बट अब होना चाहिए, पहले नहीं था अब है। ये देखिए 10.2 का मैक एड्रेस इसने लर्न किया। तो देखिए होता क्या है कि जब आप कम्युनिकेट करते हैं ना किसी भी मशीन से दूसरे मशीन को, मतलब आप यहां से जब आप पिंग करते हो किसी दूसरे आईपी एड्रेस को, तो जब भी आप एक आईपी एड्रेस को रीच आउट करोगे या पिंग करोगे, तो उसमें सिर्फ दो ही कंडीशंस बनती हैं। एक, या तो वो आईपी एड्रेस डेस्टिनेशन आईपी हमारे सेम सबनेट को बिलोंग करेगा, राइट? सेम सबनेट मतलब कि जो इस मशीन का अपना सबनेट है उसमें फॉल करेगा डेस्टिनेशन आईपी, एक तो ये कंडीशन है। या फिर वो फॉल नहीं करेगा उस सबनेट में, डायरेक्टली कनेक्टेड सबनेट में, राइट? यही दो कंडीशंस होंगी, या कोई थर्ड कंडीशन भी है, बताइए। एक मशीन पे जब आप मशीन से एक डेस्टिनेशन आईपी को रीच आउट करने का ट्राई करेंगे, तो दो ही कंडीशंस बनती हैं मेरी नॉलेज में, या तो वो उसके अपने सबनेट में फॉल करेगा डेस्टिनेशन आईपी, या फिर नहीं करेगा, करेक्ट? अब अगर वो डेस्टिनेशन आईपी इसके अपने सबनेट में फॉल करता है, अपने सबनेट में मशीन के, राइट, जो इसका अपना सबनेट है उसी में फॉल कर रहा है, राइट, तो ये क्या करता है, इसको पता है कि ये तो मैं डायरेक्टली रीच आउट कर सकता हूँ, बिकॉज इट्स पार्ट ऑफ माय ओन सबनेट, राइट, तो मैं इसको डायरेक्टली रीच आउट कर सकता हूँ। बट अगर वो डिफरेंट सबनेट में होगा आईपी एड्रेस डेस्टिनेशन आईपी, तो उसको इट नोज वेरी वेल कि अब मुझे गेटवे के पास जाना पड़ेगा, तो गेटवे का मैक एड्रेस मैक टेबल अपने एआरपी टेबल में देखेगा फिर यहाँ पे, जो कि पहले से था। बट डेस्टिनेशन आईपी का मैक एड्रेस यहाँ पे जो 10.2 जिसको हमने पिंग कराया, उसका मैक एड्रेस हमारे एआरपी टेबल में नहीं था। तो इसने क्या किया, बिकॉज इट नोस कि ये मुझसे डायरेक्टली कनेक्टेड है, यहाँ पे मेरे सेम सबनेट में है, तो इसने एक यहाँ पे आर्प रिक्वेस्ट जनरेट की। आर्प रिक्वेस्ट को रीड कीजिए अब आप। सो इट्स अ आर्प रिक्वेस्ट, देखिए आप। So if you look at this ARP request, इसमें कुछ चीजें आपको समझनी चाहिए। एक, इसमें कोई आईपी हेडर नहीं लगाया। कोई दिखाई दे रहा है कि आईपी हेडर है इसमें? क्या आईपी ने इसको इनकैप्सुलेट किया?
नो, ऑल एफ।
इसको, हाँ, मतलब ऑल एफ तो ठीक है, ऑल एफ तो देख लेंगे वो, बट बीच में अगर आप देखोगे तो आईपी इज नॉट इन्वॉल्व्ड, है ना? सो एआरपी को डायरेक्टली इनकैप्सुलेट किया ईथरनेट ने। आईपी हेडर की मैं बात कर रहा हूं। अब ऐसा नहीं है कि इसमें आईपी की इंफॉर्मेशन नहीं गई होगी, आई एम नॉट सेइंग दैट, व्हाट आई एम सेइंग इज कि आईपी इनकैप्सुलेशन नहीं हुई है यहाँ पे, आईपी हेडर नहीं लगा इसमें, राइट? तो आप इसको लेयर 3 प्रोटोकॉल बोल ही नहीं सकते, क्योंकि लेयर 3 में जैसे आईसीएमपी आता है, अब आईसीएमपी देखोगे तो उसको इनकैप्सुलेट कौन करता है? आईपी। या जीआरई आता है, उसको कौन इनकैप्सुलेट करता है? आईपी। या कोई भी आप लेयर 3 प्रोटोकॉल ले लीजिए, यू कैन टेक एनी एग्जांपल, सभी को आईपी इनकैप्सुलेट करता है। तो अगर ये यहाँ पे क्या होता, एक लेयर 3 प्रोटोकॉल होता, तो इसको आईपी इनकैप्सुलेट कर रहा होता, राइट? बट सिंस आईपी इज नॉट encapsulating this ARP, तो वी कैन नॉट रियली कॉल इट लेयर 3 प्रोटोकॉल। तो आप लेयर 2 ही बोलोगे, तो एआरपी को डायरेक्टली इनकैप्सुलेट किसने किया? ईथरनेट ने। एंड देन ये कहां पे प्लेस हो गया? फिजिकल मीडिया पे। नाउ इफ यू लुक एट आरप रिक्वेस्ट, पहले आप एआरपी पैकेट को ही एक्सपेंड कीजिए। यहाँ पे ये एक आरप मैसेज है, रिक्वेस्ट मैसेज है ये, राइट? इस मैसेज के अंदर कुछ चीजें हैं, जैसे हार्डवेयर टाइप, प्रोटोकॉल टाइप, राइट? हार्डवेयर साइज, प्रोटोकॉल साइज, ऑपकोड या सेंडर मैक एड्रेस, सेंडर आईपी, टारगेट मैक, टारगेट आईपी। तो ये कुछ फील्ड्स हैं इस आरप रिक्वेस्ट मैसेज के अंदर, राइट? आईपी हेडर नहीं है, these are couple of fields within this ARP request message। हमारे लिए जो सबसे काम का है वो ये है। तो सेंडर मैक, मुझे पता है सेंडर का मैक एड्रेस, मतलब मशीन को अपना मैक एड्रेस तो पता ही होगा ना, तो उसने अपना मैक एड्रेस डाल दिया यहाँ पे। सेंडर आईपी इसका अपना आईपी एड्रेस है मशीन का। टारगेट मैक, टारगेट मैक तो हमें पता ही नहीं है ना, वी डोंट नो अबाउट द टारगेट मैक, और तभी तो आरप रिक्वेस्ट जनरेट कर रहे हैं हम, बिकॉज वी डोंट नो एनीथिंग अबाउट द टारगेट मैक एड्रेस। इसीलिए यहाँ पे ये टारगेट मैक एड्रेस में क्या डाला? अनस्पेसिफाइड। इसका मीनिंग होता है अनस्पेसिफाइड, बिकॉज वी आर लुकिंग टू रिजॉल्व दिस मैक एड्रेस नाउ, राइट? फ्रॉम दिस टारगेट आईपी एड्रेस। हमारे पास टारगेट आईपी तो था, बिकॉज हमने इसको पिंग कराया 10.2 को, बट वी आर नॉट हैविंग द मैक एड्रेस ऑफ 10.2 इन आवर एआरपी टेबल। और यही रीजन है कि मशीन ने क्या जनरेट किया? आरप रिक्वेस्ट, राइट? तो टारगेट आईपी है, बट टारगेट मैक एड्रेस हमारे पास नहीं है, और वही तो निकालना है। अब जब ये आरप रिक्वेस्ट इसने प्रिपेयर की, तो आरप को इसने हैंड ऑफ किया किसको? ईथरनेट को डायरेक्टली। और वो देख सकते हो आप यहाँ पे, ठीक है? ईथरनेट पे जाइए, ईथरनेट ने अपना हेडर लगाया इसके ऊपर। अब ईथरनेट जब भी अपना हेडर लगाएगा तो उसमें दो चीजें लग करके जाएंगी, एक सोर्स मैक एड्रेस और एक डेस्टिनेशन मैक एड्रेस, राइट? और ऑब्वियसली टाइप भी होता है वहां पे, तो टाइप इज ऑल्सो देयर इन दैट ईथरनेट हेडर। बट अगर आप ध्यान से देखेंगे तो सोर्स मैक एड्रेस तो ऑब्वियसली इस मशीन का अपना मैक एड्रेस रहेगा, राइट? बट डेस्टिनेशन मैक एड्रेस, लुक एट दिस, सी, इट इज प्री डिफाइंड, it is predefined that your ARP request will always be broadcasted। मतलब there is no other way or there is no other definition, और या फिर मैं ऐसा बोलूंगा there is no other scenario। ARP request is always going to be broadcasted। अब क्योंकि ARP request क्या होती है? ब्रॉडकास्ट। तो लेयर 2 पे आप कैसे डिफाइन करेंगे कि हाँ ये एक ब्रॉडकास्टेड मैसेज है? सो फॉर दैट पर्पस वी हैव गॉट दिस ऑल एफ। तो ये जो ऑल एफ होता है ना, ये जब भी आपका डेस्टिनेशन मैक एड्रेस ऑल एफ रहेगा, इसका मीनिंग होता है ग्लोबल लेयर 2 ब्रॉडकास्ट एड्रेस। ग्लोबल लेयर 2 ब्रॉडकास्ट एड्रेस, विच मीन्स कि एक ब्रॉडकास्टेड मैसेज है। और ब्रॉडकास्टेड मैसेजेस के लिए आपने सुना होगा या पढ़ा होगा, क्योंकि अब स्विचिंग तो कराऊंगा नहीं इधर, राइट? बट सुना होगा आपने कि स्विच हमेशा फ्लडिंग करता है, और फ्लडिंग होगी तो सभी के पास एक एक कॉपी जाएगा इसका, राइट? तो अब हमें यही तो चाहिए, बिकॉज वी डोंट नो एग्जैक्टली कि हमारा डेस्टिनेशन आईपी किस पोर्ट पे कनेक्टेड है हमारे विलेन के अंदर, राइट? अब क्योंकि सेम सबनेट में तो सेम विलेन में भी होगा, बट हमें ये नहीं पता कि डेस्टिनेशन होस्ट किस पोर्ट पे कनेक्टेड है। इसलिए आरप रिक्वेस्ट का फ्लड होना इज कंपलसरी। सभी के पास इस एआरपी रिक्वेस्ट की एक एक कॉपी जाएगी अब, राइट? बिकॉज ब्रॉडकास्ट हुआ है, ब्रॉडकास्ट हुआ है तो स्विच हमेशा क्या करेगा? इसके लिए फ्लडिंग, फ्लडिंग करेगा। तो अब ये जो आरप रिक्वेस्ट है, इस आरप रिक्वेस्ट की एक एक कॉपी हर एक मशीन पे जाने वाली है, राइट? मान लीजिए आपके यहाँ पे 100 यूजर्स मशीन लगी हुई है एक ही वीलेन में, तो जिसने सेंड किया उसके पास तो वापस फ्लड होकर के आता नहीं है, बट बाकी जो मान लीजिए टोटल 100 मशीन्स हैं आपके यहाँ, राइट, 100 मशीन्स एक सेम वीलेन के अंदर, तो सभी 99 मशीन्स को एक एक कॉपी आर्प रिक्वेस्ट की मिलने वाली है, राइट। अब क्योंकि ये ब्रॉडकास्टेड फ्रेम है तो एवरीवन इज गोइंग टू एक्सेप्ट दिस, राइट, सभी इसको एक्सेप्ट करेंगे और इसको ओपन करेंगे, फिर सभी ओपन करेंगे, ठीक है, इस आर्प रिक्वेस्ट को सभी ओपन करेंगे और वो देखेंगे उसका टारगेट आईपी एड्रेस, ये देखेंगे, और फिर वो अपने आईपी एड्रेस से कंपेयर करेंगे, कंपेयर विद ऑन एड्रेस, राइट, यही होता है। तो जितनी भी मशीन्स ये आर्प रिक्वेस्ट रिसीव करेंगे, राइट, वो सभी मशीन ये टारगेट आईपी को अपने आईपी एड्रेस से कंपेयर करेंगे। अब कोई एक ही मशीन होगी ना जिसका आईपी एड्रेस इस टारगेट आईपी से मैच करेगा, देयर विल बी जस्ट वन मशीन, राइट। तो एक ही मशीन होगी जिसका आईपी एड्रेस इस टारगेट आईपी से मैच करेगा और वही मशीन रिस्पॉन्सिबल होगी टू प्रोवाइड यू एआरपी रिप्लाई। तो वो मशीन अब आपको एआरपी रिप्लाई देगी और ये एआरपी रिप्लाई देगी, दिस इज एआरपी रिप्लाई। पहली बात तो ये है कि एआरपी रिप्लाई इथरनेट हेडर पे देखिए आपका डेस्टिनेशन मैक एड्रेस क्या हो गया, आप यूनिकास्ट मैक एड्रेस, बिकॉज दिस टाइम हमें पता है ना कि किसको रिप्लाई करना है, भाई जिससे रिक्वेस्ट आई उसी को तो रिप्लाई करना है। तो वी नो वेरी वेल कि whom we are going to reply now, right, we know it very well, मतलब मशीन knows very well। तो मशीन ने डेस्टिनेशन मैक एड्रेस में वही मशीन का मैक एड्रेस यहां पे ऐड किया जहां से इसको आर्प रिक्वेस्ट रिसीव हुई थी। तो वी कैन इजीली सी कि ये जो आर्प रिप्लाई है दैट इज ए यूनिकास्ट मैसेज, और ये हमेशा ऐसे ही रहने वाला है। आर्प रिक्वेस्ट हमेशा ब्रॉडकास्टेड रहेगी और आर्प रिप्लाई हमेशा, राइट, यूनिकास्टेड रहने वाला है। और ये चीजें ऐसा नहीं है कि F5 में है, ये इट्स लाइक इट इज पार्ट ऑफ द CCNA, राइट। जब सिस्को में हम CCNA करते हैं या बेसिक्स जब भी हम कवर करते हैं नेटवर्किंग के, वहां भी यही चीज आती है। मैं बस आपको रिफ्रेश करा रहा हूं यहाँ पे, ठीक है, मेमोरी को। तो एआरपी रिप्लाई भी आपका यूनिकास्टेड है और एआरपी रिप्लाई में देखिए क्या क्या चीजें ऐड होकर के आई है, ठीक है। जैसे अगर आप ध्यान से देखेंगे तो यहाँ पे फिर से सेंडर मैक एड्रेस, तो उसने अपना मैक एड्रेस दे दिया और सेंडर आईपी 10.2, और इसी का तो मैक एड्रेस चाहिए था हमें, यही तो चाहिए था। तो एआरपी रिप्लाई में ये इन्फॉर्मेशन आ गई है। और टारगेट आईपी, टारगेट मैक एड्रेस तो खैर इसने लगाना ही था यहाँ पे इस बार, बिकॉज इट नोस की या इट न्यू कि फ्रॉम वेयर आई रिसीव्ड द आर्प रिक्वेस्ट। तो एआरपी रिप्लाई को अगर आप देखोगे तो इट इज कंटेनिंग अगेन सेंडर मैक सेंडर आईपी। तो अब जब इसने ये एआरपी रिप्लाई दिया और ऑब्वियसली ये वायर पे आ गया और फाइनली कहाँ पे आएगा, आपकी मशीन के ऊपर आ जाएगा, यहाँ आ गया ये। और इसने फिर एआरपी टेबल में एंट्री भी क्रिएट की, अगर आप ध्यान से देखोगे आप वो एंट्री भी देख सकते हो, ARP-A। तो जो 10.2 है उसका मैक एड्रेस आपको यहाँ पे दिख जाएगा एआरपी टेबल में। एक चीज ध्यान रखना, जो एआरपी टेबल में जब एक बार एंट्री आ जाती है ना तो वो वैलिड होती है कितने टाइम के लिए, बताएगा कोई? 4 आवर्स के लिए। उस बीच में अगर ये मशीन रिबूट नहीं होगी ना, रीस्टार्ट नहीं होगी, तो it will keep that entry in its ARP table for 4 hours, 4 घंटे के लिए आती है ये।